and thank you very much to the organizers for inviting me to give this talk. Yeah, my name is Daniel Thédié, and yeah, I'm going to talk you through Ambient Viewer, which is an online tool for sleep data visualization. So firstly, a very short bit about my own background, because I'm not a light or circadian researcher by training to start with, although I started my academic career in my PhD by working with light, but in a very different context, which is of fluorescent proteins and microscopy. And I then moved on to a postdoc in microbiology and still working with fluorescence microscopy. And eventually that led me to becoming a research software engineer and really focusing on making tools for researchers. And as part of this, I am writing pieces of software for research, as well as maintaining the BioDare2 platform, which I'll touch on at the end of this talk. I am now part of the BioRDM team at the University of Edinburgh that's led by Professor Andrew Miller. So BioRDM stands for Biological Research Data Management, and it's a team made up of domain specialists who try to assist researchers in managing their data in their day-to-day research. And the BioRDM team is involved currently in the Ambient BD project that Amy just mentioned earlier. And this project is looking at the relationship between bipolar disorder, sleep, and circadian rhythm. It has many different aspects, but the one I'm going to really focus on here is that it includes long-term sleep monitoring for 180 participants over 18 months. So a fairly large amount of sleep data is being collected here. And the main question that the study is trying to answer is, how do sleep and circadian rhythm influence clinical outcomes in bipolar disorder? So to collect this long-term sleep data, the team has been using Somnify devices, which is a relatively recent technology that's based on radar, and it records sleep onset and wake-up times, a lot of different environmental parameters, such as ambient light, but also sound, temperature, and some physical parameters like respiration and heart rate. The main advantages of using that technology is that it's very unintrusive. There's no wearables at all. There's just this small device that participants can put on their bedside table, and it's very low maintenance. So it makes it very suited to this type of longitudinal studies. And as I said, this is going to produce quite a lot of data over the course of the study. So the challenges associated with exploring this sleep data are that they are quite large data sets. So it's daily sleep monitoring for about a year and a half. It's a fairly new technology, so there are very few tools that are already available out here. And as with many types of data, there is a level of filtering and curation of the data that is necessary. For example, it's possible to have spurious events if pets come into the participants' rooms. So in terms of data analysis, the requirements were that we needed to have some specific sleep metrics and visualizations for the sleep data. And we wanted to be able to create workflows for data processing that would be easy to change, that would give the researchers quick feedback on the effects of the processing. It has to be reproducible and scalable to cater for the large cohort of patients. And finally, it was important to be able to adapt to different coding abilities of the researchers, from no experience in coding at all to already quite confident using R, the R programming language. So our answer to this was Ambient Viewer, which comes both as an online app and an R package. So the app allows to filter the data based on a specific set of predefined filters that can be used that are dedicated to this type of data. Data checks to ensure good data quality, and graphs, visualizations. The advantages of using the app are that it's interactive. It requires absolutely no coding knowledge and is very useful for quick data exploration. On the other side, we have also an R package, which provides a set of functions that basically allow you to perform the same tasks, but in a coding environment. And that is more useful to make analysis workflows, to fine-tune figures, or to do batch processing of data. So this is what the Ambient Viewer app looks like at the moment. The goal is that it presents a sort of dashboard where everything is accessible quite quickly. You can see up here there is a section to input data, and you can also load example data if you just want to test the app and you don't have any of your own data yet. There is a section for filtering, and any data filters that are applied in this section will directly affect these two sections, which are different data tables with metrics and statistics and figures. And the app is currently available, reachable at this address here. This is an example of a few of the visualizations that can be produced by the app. For example, these are 3 different visualizations around measuring the times at sleep onset, wake up, and mid-sleep, including grouping by day of the week, or it's also possible to group by working day versus non-working day. Another useful feature of the app is that the data can be manually annotated. And so that can be really useful to cross the sleep data with different kinds of data, such as, for example, questionnaires that are given regularly to participants. And it makes it really easy to manually add annotations on certain data points, certain sleep sessions, and see it reflected in the figures to help detect trends and patterns. Finally, a feature that I think can also be really useful is this sleep report. So this is a report in PDF format that can be directly exported from the app on the processed data, and it can then be given in particular to participants to give them access to the data in a way that is meaningful and pre-analyzed, so that they have they can get some ideas of what their sleep data contains and represents and can be used for. So here I've been talking mostly about the app side of things, but at some point it can be really useful to dig a bit deeper into the code side of things and the R package. So on GitHub, there is a wiki that includes extensive documentation on how to install and how to use the package. And this is, for example, a small example script which loads Somnify data, applies a few different filters, and generates the sleep clock visualization as well as a sleep report. And so this kind of script can then be easily modified to, for example, customize figures or to batch process a lot of data from different patients quickly and at the same time and reproducibly. So the main takeaways of this are that we were able to create a bespoke analysis tool for sleep data and to adapt to the needs of researchers. And that enabled efficient workflows at different stages of the project. It also enables sharing meaningful data with study participants easily. And finally, all the code is shared openly on GitHub, which helps with both reproducibility of the analysis and potential reusability for different projects. And now I'm going to quickly touch on another subject, which is BioDare 2. So some of you might already have heard of BioDare or even already be using it. So BioDare 2 is an online repository and analysis platform for circadian data. You can reach it at this address, biodare2.ed.ac.uk. And if you work with circadian data and you haven't yet used it, I really encourage you to try it out. I think it's it's a really nice and powerful tool. In terms of analysis, it allows you to do detrending, normalization, alignment, and period analysis, among other things, and to generate, again quite beautiful figures. On the last count, we had about 1,800 users located roughly all over the world. And we have an increasing number of experiments and time series on the website. So experiments are made public automatically after 3 years. And at the moment, there are about 11,000 experiments that are publicly available. So you can go on there, browse experiments, and find things that might be of interest to you. So with this increasing number of experiments, we had to develop a couple new features. One of them that we've added recently is that we've added some advanced search options. So now instead of only being able to search by keywords, it is possible to search experiments by species, data category, author name, and creation date. And finally, we've very recently added on the homepage of BioDare a weekly featured dataset, which is a public dataset on BioDare from a list of curated high-quality dataset that have really informative metadata. And this is an attempt at promoting the really good quality of research that is hosted on BioDare, and also to encourage people to really use to really fill in meaningful metadata to their experiments. So if you have data on BioDare, or if you do in the future and you think you have a data set that could be featured on the homepage, then please feel free to send us an email at biodare@ed.ac.uk, and we'll be happy to add that on the homepage as well. And with that, I'd like to thank you for your attention, and yeah, feel free to try our tools.